Hello and welcome. In our lesson today, we are going to discuss reversible reactions. So most chemical reactions tend to be irreversible, permanent. That is, once done, that's it. Now, an example is the combustion of carbon. When you take carbon, charcoal for example, heat it in the presence of oxygen, what happens is that carbon dioxide gas is formed. Now, this is a permanent chemical reaction. You cannot say that if you were to take the carbon dioxide gas, then somehow you can manage to obtain carbon and oxygen. Impossible. So my point is this: a lot of chemical reactions are irreversible, but there are a few chemical reactions that are reversible, meaning that depending on the conditions present, either the forward reaction or the backward reaction can happen. Now for this discussion, let me use the example of ammonium chloride. Now let us discuss the reason for this. So if you were to take ammonium chloride, place it in a boiling tube and heat it, what happens is that it's going to dissociate because of the heat. This is known as thermal dissociation. Now it's going to dissociate to form two gases, ammonia gas and hydrogen chloride gas. So what happens is that these two gases are then going to diffuse to the upper parts of the boiling tube where it's cooler, and then they will recombine with one another to form ammonium chloride. So we have two reactions taking place. We have the forward reaction, whereby ammonium chloride is dissociating to form ammonia gas and hydrogen chloride. We also have the backward reaction, where these two gases are recombining with one another to form the ammonium chloride. So this is an example of a reversible chemical reaction. It can occur in either direction, either the forward direction or the backward direction, depending on the conditions present. In this case, it's temperature. Now, let's pause there. I have a question for you. Now, this question is a bit off topic, but let's consider its revision. If I were to take a moist red litmus paper, place it on the mouth of a boiling tube containing ammonium chloride, and then heat the ammonium chloride, what am I going to observe with regards to the litmus paper? So we have our moist red litmus paper. So what changes of color will we see in the litmus paper? Or will there be no change at all? Okay, I think that should have been enough time to formulate an answer. Let's now discuss it together. So we are saying that ammonium chloride on heating decomposes to form two gases, ammonia gas, which is a basic gas, and hydrogen chloride gas, which is an acidic gas. So these two gases are then going to diffuse to the upper parts of the boiling tube where we have our moist red litmus paper. Now, the rate of diffusion of the two gases is not going to be equal. Ammonia has a smaller molecular size, so that means that it's going to diffuse at a faster rate. So it's going to reach the litmus paper fast. Now it's going to dissolve in the moisture to form ammonium hydroxide, which is a basic solution. So it's going to turn the red litmus paper blue. Now, for the hydrogen chloride is behind. It has a larger molecular mass, so it's still diffusing, but at a slower rate. Now, it's going to encounter the litmus paper after ammonia, dissolve in the moisture to form hydrochloric acid. This, of course, is acidic, so it's going to turn the now litmus paper from blue to red. And there we have it. We're going to have the litmus paper turning from red to blue because of ammonia, and then blue to red because of the hydrogen chloride gas. Okay, I hope that was beneficial. Now let us go back to what we had been discussing before, reversible reactions. Now let's do another example of a reversible chemical reaction, copper 2 sulfate. Now copper 2 sulfate can be hydrated or anhydrous. Now, hydrated simply means it contains water of crystallization, and this is in form of blue crystals, blue beautiful crystals. Now, if you were to heat these crystals, what will happen is that they lose the water of crystallization and in turn form anhydrous copper 2 sulfate, which is a white powder. So that is our forward reaction. copper 2 sulfate losing water of crystallization to form anhydrous copper 2 sulfate. But the backward reaction can also take place. So in this case, if you were to take a little bit of water, add it to some of the anhydrous copper 2 sulfate, it's going to change it to blue. Blue crystals will be formed. Why? Because it turns back to hydrated copper 2 sulfate. So those are two examples of reversible chemical reactions. Now, when illustrating this using a chemical equation, we use the double arrows as such to show that this reaction can occur in both directions, either the forward direction or the backward direction. And that is that on reversible reactions. In our next lesson, we are going to discuss equilibrium. See you there.